Was COVID our biggest healthcare challenge? Well, what a challenge it was if we think back to where we were 2 years ago and where we are today with some sense of normality returning, and think about how we got there in terms of the rollout of vaccines. Actually, that was a big engineering challenge. Being able to upscale production, being able to transport and store vaccines at the required temperature. Engineers played a big part in addressing that particular healthcare challenge. Was it our biggest? Well, who knows, but it's certainly not our only healthcare challenge. Wound care is another global challenge. So to put this into a little bit of perspective, the annual cost of chronic wounds is estimated to be around 3% of the total cost in any industrialised country. So for the UK alone, that amounts to in excess of £5.3 billion per year. So that's a huge amount of resource on this particular healthcare challenge. And that figure's actually set to rise in the future if we think about the other healthcare challenges associated with it, the increase in obesity and type 2 diabetes, the ageing population, are all factors which contribute to this area. So when I first started looking at this research area, my only real experience of wounds was a graze or a cut that I maybe had when falling over as a child, a cut caused by a knife when I was inexpertly chopping onions. But I very quickly realised in attending forums such as wound care conferences with communities of nurses who were looking into how to improve outcomes for people with wounds, you can't just stick a plaster on it. Just to highlight this, I'm really privileged in being able to work with a number of professionals from the NHS and other healthcare settings, and a colleague of mine, Dr. Leanne Atkin, who's a vascular nurse specialist in a local hospital, has a patient called Tracy. Tracy's given us permission to share pictures of her wounds. She was 29 when she first developed a venous leg ulcer and lived with a chronic non-healing wound for over 5 years. At the time, she had 2 small children. So it's really easy to think about wound care as also something that affects older people. But we've got a woman here, in her 20s, living with a chronic wound. I will be putting an image of the wound up, so if you are of a sensitive nature, please feel free to look away. This is Tracy's wound, and you can see it's still there 3 years later, from 2015 to 2018. There's changes in the colour, but you can see it still looks sore. It still looks like a serious problem for her. And I'd like to share her words with you about the impact it's had on the quality of her life. So as you can see, it has impacted her ability to get out there, her confidence, and it's probably impacted those people around her as well. So when we think about wounds, it's not just something that you can stick a plaster on. It's a serious healthcare problem that affects people of all ages, of all backgrounds. So why is skin important? Well, as an engineer, materials are very important to me. We use materials, we manipulate materials to solve problems, we investigate materials and how they interact with the world around us. We constantly develop new materials to look into different areas and to solve other challenges. And skin as a material is absolutely fascinating. It's a living organ, it's the biggest organ of the body, and it protects us, it provides a barrier to external issues that might, so things like bacteria. If retaining the skin's integrity is critical to sustaining life. It regulates our temperature and it's a mechanism for feeling pain, so protecting us, but also feeling pleasure. the touch of the grass, the touch of water running on our skin. You know, it's so important to our well-being as well as our health. And what can we as engineers do with skin? Well, we've been able to scan and visualize different components. We can do that with skin as well. You can see here a representation of a healthy volunteer being scanned. You can see the leg in quite some detail. Actually, if you got up close to that, you could see each hair on the leg. And if you think back to that picture of Tracy's wound, don't worry, I won't flash it back up for everybody. But if you think back to that picture, it was very difficult to see at what point that might have been healing or getting better, or at what point it wasn't getting better. So when we're trying different treatments, actually having a good way to visualize what's happening to that wound, being able to quantify the color and the shape and the depth, can give us a good predictor of what's working and what's not, so that we can either continue treatment or very quickly change it so that we can make an impact much quicker on people living with these chronic wounds. So form and texture are really important to understand how the skin heals, but also how it interacts with the world around us. Another thing that we can measure, and why measurement's so important to me, I should mention, is because my background is in mechanical engineering, but also in metrology, which is not the study of the weather, that's meteorology. Metrology is actually the science of measurement. So looking at measurement and how we can use that in engineering to solve problems, to make things better. And in my personal passion, I'm sure you can see, is helping use it to solve people's problems in improving their quality of life. We can understand the skin at a much smaller level as well. So what you can see there is 3 images of different skin textures from different people. And you'll notice that they're quite different. Actually, the colour variation shows the depth of the texture on the skin. I don't want to call them wrinkles, but we'll call it texture on the skin. You can see at the top we've got a 23-year-old female, a 24-year-old male in the middle, and then a 57-year-old male at the bottom. And that variation in skin obviously will also vary with the way we treat our skin, how hydrated we are potentially. You will have seen on adverts for skincare products, 71% of 230 women agree that this product made their skin softer. Actually, with technology like this, you can put a number on it of how much softer, how that texture's changed. And for wound care, we can start to look at how different people's skin interacts with different surfaces for healing, but also in other situations. And that's another one. What happens when care results in harm? So the interaction of skin with different devices can cause issues, potentially. You see there on your screen a pressure ulcer that's been caused by somebody being in contact, that's the sacral area, so at the bottom of the spine, being in contact with the surface for a prolonged period of time, therefore causing damage to the skin. So then we've got a wound that we need to heal. Well, what if, as engineers, we could help the healthcare community to prevent these ulcers happening in the first place? And that's one of the things that we've very much been looking at. So pressure is something that as engineers, we start to understand very early on in our education. So even in A-level physics, you start to understand that pressure is force over area, so the amount of force exerted over a certain area. And there are devices that can help to redistribute pressure. So we can't completely eliminate pressure on the body. If something's in contact with the body, you will incur some pressure. Unless we levitate all our patients, which obviously technology is not quite there yet. But if we can redistribute that pressure, even it out over areas so that we can reduce it in particular places, that means that we can start to reduce the number of pressure ulcers that occur. They don't just occur because people lie down. You will think back to the news stories where we saw images of doctors during COVID with red marks around their faces, where respirators and pressure and PPE, so the masks that they were using to preserve themselves from getting an infection, they were causing damage to the skin. So it's not just about people on mattresses, it can be devices which cause this as well. So as engineers, if we can understand before those devices are used what kind of peak pressure points there might be, then we can understand and help to develop solutions to those problems. On the screen, you can see a pressure map of a person lying down on a mattress, and the lighter colours and the red areas are where we're seeing peak pressure. And actually, it's at places like the base of the spine, the back of the head, and the back of the heel. So anywhere you've got a bony bit that sits underneath your skin, that causes a peak pressure. If we can help develop devices to relieve that pressure, and if we can understand those measurements, then we can go some way to redressing the problem. And this is the result of that study. So those pictures can obviously then be turned into numbers. We can use a little bit of mathematical knowledge to look at the prevalence, the number of peak areas of pressure for a particular device. And we might think that all mattresses are equal. You know, we might go to IKEA, lie on all the mattresses, think that they're fine. All the mattresses that we put into hospitals, are they all the same? Well, actually, no, because you can see there the difference between a few different mattresses in terms of the peak pressures that are caused. Now, for most people, the mattress that shows the highest number of peak pressure areas might be absolutely fine because they're healthy, they've got good skin integrity, they're well hydrated, they don't have any underlying conditions. But if you go in as a patient with issues that might make you more susceptible to pressure ulcers, then information like this can help us to say, well, let's put you on a more expensive mattress, a mattress that's got more technology there to help relieve your pressure and to help reduce the chance of you getting a pressure ulcer. So there's lots of ways we can start to use technology to address these types of issues. And what if we could predict that? So rather than just measuring what happens with existing situations, existing products, there's some terms there that as engineers we're really familiar with. So I've said before, pressure is force over area. So how much force is over a given area will give you how much pressure is being applied. And a nice analogy I like is that actually a woman in stiletto heels is more deadly than an elephant, because when you put the pressure through a tiny point on a heel, it's actually going to hurt you far more than the pressure of the size of an elephant over a big foot pad that they've got. Friction, there we've got the resistance of movement between two surfaces. So how much we resist movement between two surfaces. So if you think you're lying on a mattress, you've got pressure, you move, so you've got some friction because there's resistance between you and the sheets or what you're wearing. And that actually causes shear. So that causes the material in your skin and the material of the mattress to move. And it's that shear motion that then can start to damage the skin. If you've got prolonged pressure on your skin and shear with the addition of friction, that's what causes the issues. And the other thing is obviously mechanical properties of skin. So how skin behaves, I've already talked about some of the factors, might be hydration, it might be age. We all know that our skin becomes less elastic as we get older, and that can really influence the mechanical properties of the skin. And what we can do as engineers is to look at putting this into simulation models. So understanding those factors and putting those factors into what we use as a tool as engineers is finite element analysis, FEA. So we can break down an area of material and look at meshing it so that we can get a good understanding at each part in that, to look at how the skin deforms, to look at the stress and strain within the skin, and start to make predictions about how it will fail. That's an engineering term, so your skin doesn't necessarily fail, but how that integrity might be broken down and how wounds might develop. So wound care really is a technological challenge. Simon mentioned in the introduction that I work within the Institute for Skin Integrity and Infection Prevention. We work cross-disciplinary, so I get to work with the healthcare professionals that I've mentioned, people from pharmacy, people in other engineering disciplines, people in computer science, bringing together all these people to look at how we can advance wound care technologically so we can support those medical professionals in what we call a bench-to-bed approach to make sure we're having an impact on people's quality of life. Looking at materials, evaluation and how we might evaluate wound healing, looking at the data, so mathematicians working on data analytics to see what works, how we can prevent things, how we can make people's lives better through innovation. So I hope I've given a very brief overview of how engineering really is at the heart of healthcare. And there are some other things that engineering's had a massive contribution to there on the screen. So diagnostic tools such as MRI and CT scanners, you can imagine without electrical and electronic engineers and mechanical engineers, they wouldn't be possible. Hip replacements, knee replacements, so making sure that people can stay pain-free as they're ageing with the ageing population. In the centre there, that's sort of the weird little device on top of a fingerprint, so that's a fingerprint, so it shows the size. Advances in manufacturing means that we can develop things like stents, and a stent would be used to pop inside an artery or a vein to make sure that it doesn't collapse so that your blood flow can continue. I know my mum had one of those before she had a heart bypass to keep her ageing heart going, which I'm very grateful for. And then other things like development of mattresses, wound care itself, and in the bottom corner there, you've got a stoma bag, which will help people with issues such as bowel problems continue to live normal lives, retain dignity. And these are all inventions that really, in the past would have meant a real reduction in somebody's quality of life. With engineering and technology, we can hopefully really prolong that. Finally, I'd like to dedicate this talk to a friend and colleague, Dr. Violetta Holmes, who worked at the university. She was a brilliant international woman in engineering, and we sadly lost her earlier this year. Thank you.
Well, thank you very much, first of all, for a fascinating lecture. Very, very interesting topic that you explained there, and clearly making a big difference to people's lives. Can I ask you, first of all, Leigh, what inspired you to become an engineer and why you chose to work in this particular area?
Yeah, so that's probably quite a long story going back to when I was at school. I actually sort of chose my A-levels because I wanted to do medicine. And with a couple of part-time jobs and discovering life at the age of 17, it was evident that I wasn't going to get the exceptional grades needed for medicine. My other love was cars, so I loved driving, I loved cars. Top Gear magazine was often landing on my doorstep.
I'm surprised.
And so I thought, well, engineering, because I related engineering with cars.
Yeah.
But fortunately then throughout my degree, I found that there were a lot more things to engineering than cars. And I got to go back to my first passion, which was helping people through quality of life and focusing my engineering on medical aspects, which is what I focused my doctoral work on. So yeah, it came full circle really, because I get to call myself doctor and through my PhD, and I get to impact on medical areas, which
Fantastic. And you're still interested in cars?
A little bit, but less so now, yeah.
Great. Another thing that struck me as you gave the lecture, Leigh, it's a very multidisciplinary area, isn't it? You explained that. That must cause some challenges. How do you overcome those challenges? How do you engage with all the people in the different disciplines?
I think it's finding a common language, first of all. So, just working in a multidisciplinary and realising that there are experts in different things and bringing expertise together. Because obviously I'm not expert in the biology of wound healing, but I work with colleagues across the university and outside of the university who are. So when we bring our pooled expertise and resource together, I think that's when we can have a real impact. And making sure that we include the patient voice and clinicians in any innovation work so that we know it's actually going to be meaningful when it hits the wards.
Yeah, great. And a final question from me. The technology in the different areas is clearly changing and developing. I mean, some of the things that you're doing is improving it, and I guess other things as well. What do you see coming in the future? Will that dramatically change the way that we can support people to have better quality of life?
I think something that's really moving forward is personalised medicine. So looking at actually tailoring medical interventions to the individual so that it'll have an impact. And I think with wound care, using the measurement technology and being able to use manufacturing technologies to make sure that we've got patient-specific solutions. And also better use of data. So one of the things Violetta worked on was high-performance computing and the capacity that gives us to be able to process data and to be able to look at much bigger picture. Things like that I think are really going to have a good influence.
Yeah, okay. Sounds fascinating. Okay, we'll open up to the floor for questions then. Does anybody have any questions, please? So the question from the live stream is it mainly older people who get problems from chronic infection from wounds?
I think it is a problem as as your skin deteriorates, but as we saw from the presentation, the lady in question was 29. Yeah. So very much it's a thing that affects globally and across the age groups, right from children up to people in later stages of life.
Right. And I guess that's another area where you previously mentioned that you can tailor the treatment to the different skin. I mean, maybe people at different ages would need different types of treatment as well.
Yes, yeah. And detecting wounds in different types of skin is a real sort of challenge in terms of a lot of the information that might be in the domain at the moment is very much focused on older sort of white skin, but it's a huge sort of challenge to be able to educate and develop technology for a much broader spectrum. Yeah.
Good, thank you. Any other questions? So the question is from Emma, who's a previous student here at the University of Huddersfield. She thanks Leigh for the presentation and echoes the sentiment and International Women Engineering Day, and just comments that it's an important topic, and thank you for sharing it with us all. Okay, the next question, what did you study at degree level, Leigh?
So my degree title was Engineering Design, Mechanical. So it was basically mechanical engineering design. And I think at the time I was really focused on, I was going to go and design cars for Jaguar Land Rover, which were located in my hometown of Coventry. So, yeah.
And looking back, was that the right degree for the type of work that you're doing now?
Yeah, absolutely.
Mechanical.
Yeah, and it was problem-based learning. So, I learnt very much problem solving, learnt about materials, design, how to apply maths to problem solving in the engineering context. So it was absolutely the right choice for me.
Good, fantastic. Okay, thank you, that's a good question. So what's the strength of this university in terms of this type of research?
I think the strength of this university is very much that we work across different disciplines. So we work really closely with colleagues from pharmacy, from nursing, from the applied sciences. And also, we attract really good collaborations with clinical partners, with industry. So a lot of this work obviously has to be very industry focused because it's about getting products that will help people's quality of life, and that is through working with our industry partners. Yep. And we have fantastic talent within our staff and our student base, so drawing on that talent to contribute to this obviously makes a big difference.
Okay, could this work lead to the development of artificial skin, was it, and triage and linking to burns and bandages? Sorry.
Yeah, so that's a really interesting area, and it's not something that I'm directly, my research is directly working on, but yes, if we can measure and characterise skin and then find manufacturing techniques to reproduce it, I think that feeds into that personalised medicine and being able to get barriers. It's about creating a barrier so that we can heal in the right conditions without infection. So being able to print skin would be a great way forward, and I think that there are researchers working in that space.
Wow. Okay, where do you see yourself in the next 5 years?
Gosh, it's like an interview, isn't it?
You've got the job.
Yeah. So this is an area that obviously I'm really passionate about, and I think just bringing more people together to work on this, and also shouting about it, really. I think it's not really the sexiest of subjects for an engineer to work on. You don't think of wound care and think engineering and technology can contribute here. But I think by more people getting involved, you can see the massive impact that it could have, not just financially. That £5.3 million a year spent by the NHS is a lot of money, but also on a personal level for people like Tracy, who, this could really help improve their quality of life.
Yeah.